Hello Year 9. You need to get a pen and a pencil, something to write on. We're going to do a quick quiz. You're going to be looking at pictures and you're going to be deciding what's the input energy, what's the waste energy, and what's the useful output energy. Okay, so if you don't have a pen and pencil and piece of paper ready, pause the video and get them ready. Okay, so we're going to go through each question. We're going to go question and then answer. You need to tick and cross and correct your work. Okay, and you're going to be submitting your scores as part of your work this week. So, first one is, what's the input energy from this picture? It's a light, so the input energy is, after you've written it down, electrical energy. If you've got electrical energy, give it a tick. It's the input energy into this light. The main useful output from this fire. What's going to be the main useful output? What's the job of a fire? If you put thermal energy, give yourself a tick. If you put heat energy, you can also give that a tick. The idea of the fire is it gives out heat. The waste energy from this power plant. What's the waste energy? The waste energy is thermal energy or heat energy. Give yourself a tick if you've got that one. The useful energy from this this car. Car needs to move. The useful energy will be kinetic energy. Give yourself a tick if you've got that one. You can have it the abbreviation K if you want. And next one, the main input type of energy from this hydroelectric power plant. What's the input energy from this power plant? Well, the water is lifted up very high. The water is lifted up high. It's going to have lots of gravitational potential energy. GPE for the abbreviation. Okay, is the input energy. It's transferred into electrical energy. It's transferred into kinetic, then electrical energy, I should say. Okay, but it starts off as gravitational potential energy. Next, what's the main input energy from the wind turbines? So the wind is moving, so it's got to be kinetic energy. Okay, kinetic energy. Kinetic energy. So input is kinetic, output will be electrical. This is an important one because we're going to be looking at this week. Next one, a pretty tasty looking sandwich. Okay, what's the main useful output energy? What's the output energy from a sandwich? Chemical energy. So this has got a big store of chemical energy inside the sandwich, and I'm going to eat it and take that chemical energy into my body. What's the waste energy in a toaster? What's the waste energy in a toaster? The main waste energy in a toaster. Don't be tricked. Thermal energy. Okay, it's not light, it's not sound. Okay, a lot of the waste energy, a lot of energy is going to be wasted with heat just coming out of the toaster above it. Above the toaster gets very hot. Don't check it, it gets very hot and it'll burn you if you put your hand over it. Okay, but lots of that energy will escape and not actually go into toasting the toast. Okay, so thermal energy will be the main waste. You can also write heat energy. Okay, what's the main useful output energy of these parachutists? Kinetic energy. They don't run out of a plane. They're transferring their gravitational energy into kinetic energy, so it's fun. So they move really fast. A star, the sun, Earth to scale. Okay, what's the main input energy? What's the input energy in the star? Be nuclear potential energy or nuclear energy. Okay, so there's nuclear energy store within the star that is transferred into heat and light and all the rest. So take a screenshot of your scores, upload that with this week's activities. Okay, now this week, as I said, we're going to look a little bit at wind, but we're also going to look at two other really important energy resources. We're going to look at wind, we're going to look at solar, and we're going to look at geothermal. Okay, now we've looked at energy resources as a general overview. Now we're going to look at a little bit more in depth in some of them. Okay, so we're looking at wind, solar, and geothermal. Now you need to know the basics of how each of these work, what are the energy transfers involved, and what are some of the advantages and disadvantages of them. Okay, so I've got wind turbines. There's a cutaway of this wind turbine, or a similar one. Okay, and we need to know that kinetic energy in the wind, okay, causes this propeller to spin, and it's connected to this turbine inside here. There's some gears, and this is connected to a generator. So this kinetic energy from the wind is transferred into this turbine, which spins the generator, which transfers that kinetic energy into electrical energy. Okay, the engineering behind them is incredible. Okay, so there's quite a lot of complexity. They need to be able to control the pitch, so how turned the blades are depending on the strength of the wind. They need to rotate around to find the optimum position to get the most energy from the wind, so you don't want to point it to the sideways on. You need to be able to measure which direction that is. They need to be able to adjust and change. So the engineering that goes into them is quite incredible. And there's lots of these turbines you can see dotted around Cornwall. Okay, especially around Newquay actually. Now, they've got some really good advantages. No carbon dioxide produced. They're renewable. And they've got low running costs. They take up a lot of space, and lots of people will say they look ugly. They spoil the landscape. Now, I think they look brilliant. I think it's amazing. When I see a wind turbine farm driving around the country, I think it's brilliant. I think it's a little bit of the future that we can have just here, and it's wonderful. But some people don't like the look of them, and they do take up a lot of space. They've got a very high initial startup cost. Okay, so it costs quite a lot of money to produce the turbines and then install them, because you need to ship them around to the different parts of the country, different parts of the world, and that takes up quite a lot of money because they're big. They're difficult to transport. Okay, so they do have a high initial startup cost. The biggest disadvantage of wind is it's not reliable. We can't accurately forecast how much electricity a wind farm will give in a given day. We have a good guess over the course of a year. We can figure out on average how much they might produce, but we can't predict reliably when that electricity will be produced. Okay, so it wouldn't be wise to just rely on electricity to generate, just rely on wind to generate our electricity. Okay, because there's going to be some days where it's not windy at all across the whole country and we wouldn't be able to generate any electricity at all. Okay, so that not being reliable is very important. Okay, now solar cells, don't get confused between solar cells, PV cells, and thermal heaters. Okay, thermal heaters, you can see them on the top of some buildings where they've got these pipes or sometimes different shapes, and these are filled with water. And the sun comes down and it heats up the water, and you can use it as a heating system or just heating up hot water. Okay, they are different from PV cells, from solar cells, which transfer light energy directly into electricity. So don't get confused between the two. Now we're talking at the moment about generating electricity, so we're talking about these PV cells. Okay, and they sort of work like a battery, that you connect two ends to the solar cell and it will generate a current. It will provide you with a potential difference, a voltage. Okay, but it needs to be in sunlight. Now these are you might have one on your calculator. Lots of calculators have a little PV cell, a little solar cell that will charge their the internal battery and get the calculator to work. It converts sunlight directly into electricity. Okay, it's got zero running costs. When it's up and running, it's got almost zero running costs. Okay, you might need to clean the glass protective covers on them every so often, but in the grand scheme of things, it has got very, very low, almost zero running costs. There's no carbon dioxide produced when they're running. They are renewable. Disadvantages, it's got a very high startup cost. The materials and the engineering that goes into producing these PV cells is expensive. Okay, so it's got a high initial startup cost. They also take up quite a lot of space. Not as much as maybe wind turbine farms would, but they do take up quite a lot of space. And they're not reliable. Okay, not as bad as wind, but it's difficult to predict how much electricity they'll produce, because they're going to produce more electricity on a sunny day than they will on a dimmer day. Okay, and obviously they won't work at night time when there's very, very little light. Okay, so those are the main advantages and disadvantages. Finally, we've got geothermal. Geothermal is a brilliant technology. So we've got hot rocks under the ground. Okay, they pump water down into these hot rocks, it gets turned into steam, and this steam drives a turbine which is connected to a generator which gives us the electricity. Okay, it's a very reliable source of energy, it's renewable, no carbon dioxide is produced. Okay, so really good method of generating. But it would only work well in some locations. So places where there are enough hot rocks to do it efficiently. So places like Iceland are very good. It's got a very high startup cost, so these power stations cost quite a lot of money. You need to drill this hole, okay, and it's difficult to do that in a scale that will work for the power station. So it's got a high startup cost. Now, your task this week, boys and girls, you've got three. and I've got a bonus one coming. So first, you need to give a brief outline of how wind, solar and geothermal produce electricity. So it's a little sentence descriptor, okay, at most 3 sentences, 1 2 sentences, okay. Use a diagram to help, okay, so draw a picture of it. Task 2, you need to write an advantage and a disadvantage for wind, solar and geothermal for generating electricity. So a pro and con for each, for wind, solar and geothermal. And third task, I need to answer these questions, so the practice ones and then the application one. Now, when you start task 1, start yourself a timer. Once you get to an hour, stop. Okay, if you finish before then, superstars, but once you get to an hour, stop. Now, that means you're only on question 2 on the practice recalls. Fine. If that means you're on question 4. Fine. If that means you finished all and you've done it in half an hour because you're a whiz kid, fine. Okay, but spend an hour. Use a stop clock, use a timer. Okay, now I've got a bonus task. And this is only for those of you who want to do it. This is completely optional. But I've got 3 examples of dingbats. Okay, I've got this one, which is misunderstanding. I've got a picture of a oh, it's covered by my face. A picture of an on button, so Newton. This is my favourite. Okay, we've got a bowl of soup. We've got an urn. And then this is a cricket scorecard, so this is 1 over. So we've got supernova. But if you're creative, I'd love to see some examples of some dingbats that you create about our energy topic. And I'd like to then be able to use some of those as a starter for our next week's learning. Okay, so like I say, this is just completely optional. You do not have to do this at all, but it'd be wonderful if some of you were able to do that. I find them quite difficult to make. Okay, but there we go. So, main activity is this. Stop after an hour. Okay, I hope you're having a fun time at home. I hope you're enjoying the wonderful weather we're having. And take care, everybody.